In this slide, we are addressing CVE 2025-27840, focusing on hidden host controller interface (HCI) commands within Espressif's ESP32 chips. These hidden commands pose potential security risks, especially for Internet of Things IoT devices that often rely on these chips. We'll explore how these hidden commands can be exploited, the resulting impacts, and strategies for mitigating these risks effectively. The vulnerability underscores the importance of understanding and securing HCI interfaces to protect IoT networks and devices from unauthorized control or access. In this slide, we dive into CVE 2025-27840, a vulnerability affecting Espressif ESP32 chips. What's particularly concerning here is the ability to execute 29 hidden HCI commands, with some being highly significant, such as the 0xFC02 command that allows writing to memory. These chips are widely used in IoT devices across the globe, which means the potential for unauthorized access and control is a notable risk. With a medium CVSS score of 6.8, this vulnerability highlights a significant security consideration. It underlines the importance of understanding how these hidden commands can impact device integrity and secure operation. The affected products mainly include the pervasive ESP32 and its associated firmware, underscoring the need for awareness and proactive mitigation to prevent exploitation and safeguard IoT ecosystems. On this slide, we will focus on the commands and exploitation aspects related to the CVE 2025-27840. We'll be discussing two critical commands, 0xFC02, which allows for writing memory, and 0xFC01, enabling the reading of memory. These commands play a significant role in the exploitation process. Exploitation of these commands typically requires physical access to the device or an already existing compromise. Once an attacker gains control, they could manipulate memory, potentially injecting harmful code that allows deeper access or control over the device. Interestingly, there's a possibility for these vulnerabilities to be utilized by OEMs during the manufacturing or testing phases, raising concerns over supply chain security. This type of exploitation could lead to unauthorized modifications or adjustments in the device firmware, paving the way for more extensive security breaches. Understanding these commands and their possible exploitation routes is critical for assessing the potential risk and devising mitigation strategies effectively. In this slide, we focus on the necessary steps you can take to mitigate risks associated with critical commands and potential exploitation. Let's dive into the fixes and best practices that you should consider implementing. Firstly, a significant mitigation strategy involves deploying firmware updates. These updates can either disable or patch any hidden commands that might exist, thereby closing potential entry points for attackers. Network segmentation is another key strategy. By segmenting networks, you can contain and minimize the impact an attacker might have if they gain access to your systems. Another crucial measure involves enhancing access controls. Restricting usage of the host controller interface, HCI, can protect against unauthorized interactions. It's essential to regularly update all your IoT devices with the latest firmware. This not only protects against known vulnerabilities, but also strengthens the overall security posture of your devices. Preventive measures also play a critical role. Implementing intrusion detection systems, IDS, allows for the monitoring of unusual activities, offering early warnings of potential security incidents. By adopting these best practices, you can significantly bolster your defenses against exploitation and unauthorized access attempts. In this slide, we're focusing on the practical application of tools to address security concerns related to undocumented HCI commands, particularly for systems using ESP32 chips. Here, the emphasis is on utilizing Ghidra, a reverse engineering tool developed by the NSA, which is pivotal for dissecting ESP32 firmware. Ghidra helps in uncovering undocumented commands that might pose security risks. To get started, you can use the command analyze headless Ghidra project name, import firmware file to import and analyze the firmware. For more detailed analysis, running scripts tailored for ESP32 can be done with Ghidra script, process firmware file, -script path to scripts/path-script.py. These commands are foundational for identifying and addressing potential vulnerabilities, aligning with the broader aim of maintaining robust security postures in IoT environments. In this slide, we wrap up our discussion on the security implications of hidden HCI commands in devices using ESP32 chips. These commands can introduce risks, particularly for systems that depend on this hardware. Therefore, it's essential to keep up to date with the latest mitigations and ensure security patches are applied timely. We recommend actively seeking firmware updates from device manufacturers to minimize these risks. Educating your teams to recognize exploitation attempts is also crucial in safeguarding your systems. Looking ahead, further research into secure configurations for IoT devices using ESP32 is necessary. It's equally important to continuously monitor vulnerabilities in similar chipsets, as these can evolve and potentially impact your security posture. In this slide, we provide a list of references that can be essential for anyone looking to deepen their understanding of the security aspects discussed earlier. For further reading, you can explore the CVE-2025-27840 entry on the NVD, which details a specific vulnerability entry related to our discussion. The ESP32 Security Analysis Report offers comprehensive insights into potential weaknesses and areas for improvement. You'll also find Espressif's official response, which can provide the manufacturer's perspective and their suggested measures for security enhancement. Additionally, tools and documentation such as the Ghidra documentation can be invaluable for those interested in reverse engineering and vulnerability research. Tarlogic's Analysis PDF is another resource that can provide supportive tech analysis, contributing significantly to your overall understanding of the topic at hand. These resources will be helpful for anyone interested in thorough technical exploration or aiming to safeguard their systems more effectively.